How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at 1.1 and 2, Chemistry and Classification of Matter. So our objectives will be to be able to classify different states and types of matter and describe their properties. So let's begin. States of matter. Basically, it's just like what phase is it in, what kind of state is the matter in. It could be in the solid state, where particles vibrate in place and are locked into position. So you can see all of these particles, they're stuck in that specific position and they can shake, but they're never going to move or flow. So solids have definite shape and a definite volume. Liquids, the particles are able to flow past each other. So in this still picture, you can see there's particles everywhere, but they're actually able to move around and flow, like a liquid, right? So they take the shape of their container and have a definite volume. They don't have a definite shape, but they have a definite volume. And then we have gases. Their particles are spread out and they move freely. So you can see there's a lot of space in between them and they're able to move around in any direction until they bump into something. So they take the shape of the container and they have no definite volume. If this container was bigger, then they would spread out more and they would take up the volume of the container. So let's talk about types of matter. So you can see in this graphic organizer, we got matter up top, and we're going to take a look at substances first. What do we mean by substance? So a pure substance has distinct properties and composition that doesn't change from sample to sample. So, it could be an element or it can be a compound. So these pure substances are one type of thing, right? So elements, it's all one type of element. Compounds, those atoms are chemically bonded together, but it's still one kind of thing. So if we take a look at elements, which is a type of substance, it cannot be broken down into a simpler substance. Most abundant elements on Earth: oxygen, aluminum, silicon, iron, calcium. So those are the most abundant elements. Probably some of them you're familiar with, right? Oxygen. All right, and if we take a look at compounds, it's made of two or more elements bonded together chemically. So they're chemically bonded together. You can see they're linked together. Which brings us to the law of constant composition. So the elemental composition of a pure compound is always the same. So what do you mean by that? It means water is always H2O. There's always two atoms of hydrogen and one of oxygen, regardless of the source. Did you get it from a stream? Did it fall out of the sky? Was it in a glacier? It doesn't matter. Water will always have this constant composition. It could also be described by mass. It could say, hey, out of this sample, 11% of it's hydrogen and 89% of it's oxygen by mass. Doesn't matter where you get that sample from. If we take a look at mixtures, which is another type of matter, so mixtures, they're physically combined. So we have a combination, right? It's a physical combination of different substances. They're not chemically bonded. So in these images, you can see that they're separate atoms. They're not bonded together. They're just mixed together. So each component retains its own chemical identity and properties. Whereas when we have a chemical combination, like say we get sodium and we get chlorine and we react them together to make sodium chloride, when we do that chemically, we have new properties, right? So sodium's an explosive metal, chlorine's a corrosive non-metal, but when they come together, you can sprinkle it on your food and not worry about it. So that's chemically combined. For mixtures, they're only physically combined, so it's just mixing them together. Composition of mixtures can vary. So, like if you're making a salad, maybe you went extra heavy on the croutons, maybe you didn't. So the composition can vary. If we take a look at heterogeneous mixtures, the composition and appearance varies throughout. So think of like a salad. Every time you stick in your fork, you might come up with a different bite, right? Every time it's going to be different. And then we have homogeneous mixtures, so homo meaning the same. So the composition and appearance is the same throughout the entire mixture. So if you ever made some saltwater solutions or you made a sugary drink where you had to mix in the sugar packet into the water and mix it up, the first sip's going to taste the same as the last sip, unless, of course, you added way too much stuff, right? So that's a homogeneous mixture. The composition is the same throughout. Air, also a homogeneous mixture, right? The air that you're breathing isn't just one thing. It's a physical combination of nitrogen, of oxygen, of some carbon dioxide, and all those are mixed together homogeneously. So summarize. Can you describe the different states of matter and their properties, meaning solid, liquid, and gas? And then can you also describe the different types of matter and their properties? Hopefully you can. I hope you found it helpful. I'll see you in class. Goodbye.